Good evening, students. Now I am going to discuss about the next part of the electric drive from module 1. Okay, so now there are several types of power converter used, but the power converter which will be depend upon the motor used in the given drive. This is very important because there are various types of power converter are in there. Okay, so first of all we have seen that AC to DC converter. So where the AC to DC converter are used, the converter is a single phase or polyphase AC supply into fixed or variable DC supply using either simple rectifier circuit or the controlled rectifier with the devices like thyristor, IGBT, MOSFET, etc. Okay, so AC to DC converter basically, because this is a AC converter which will be converted to a DC, so therefore the converter is a single phase as well as polyphase. Okay, from the AC supply into a fixed variable the DC supply, which will be a simple rectifier, the simple rectifier circuit, and the control rectifier like the thyristor. Thyristor means the SCR, okay, silicon control rectifier, whereas IGBT, MOSFET, etc. depending upon the application of this. Okay, so next we have seen that these are AC voltage control or AC regulators. Okay, so they are employed to get a variable AC voltage of the same frequency from the single phase or three phase system or three phase supply. This is very important. These are the employed for the variable AC voltage. Okay, and the frequency from the single phase or the three phase supply. Some such the controller are look like the auto transformer with the various tie-up or converters using the power electronics devices. Okay, so next we have seen that the DC to DC converter. So what is the DC to DC converter? DC to DC converter is a get the variable DC from the fixed DC voltage. This DC to DC converter is known as the chopper, which we have studied in the power electronics. Okay, so basically it will be a get variable DC voltage from a fixed DC voltage source using the power electronics devices. What will happen? It will the smooth step-less variable voltage can be obtained with the such converters. Okay, now this is an inverter basically employed for the variable or voltage or variable voltage or variable frequency from the DC supply using pulse width modulation technique, which will be a PWM, basically a pulse width modulation technique. And inverter also use the same type of power electronics devices like the MOSFET, IGBT, SCR, which will be a same as the previous. We have seen that for the AC to DC converter, that is a thyristor, IGBT, MOSFET. Here in inverter we have seen the same types of electronics devices like the MOSFET, IGBT, SCR, etc. Okay, and the next is a cycloconverter. So what happened whenever the cycloconverter is used? Basically a cycloconverter is a fixed voltage, fixed frequency, the AC supply into a variable voltage, variable frequency supply. So this is the function of the cycloconverter for the AC drives. Okay, so they are also built using power electronics devices and by using the controller at the lower power level. Okay, so these type of power converters are used in there. Okay, so what about the control unit or the sensing unit? We have seen in a block diagram that the control unit and the sensing unit. So what about the control unit and the sensing unit? The control unit control the operation of the power converter based on the input command or feedback signal continuously. Okay, and obtain from the suitable points, okay, at the load end so as to get the desired load performance. So what about the control unit or sensing unit? Basically it will be operate for the power converter and based on the input command, okay, and feedback signal continuously obtained from the suitable point at the load end so as to get the desired load performance. Okay, and also this is a several application are in there like the diesel locomotive. Okay, here seen that the diesel locomotive, okay, and the mechanical energy already available from the non-electrical prime mover in the fast converter into electric energy by a generator, then the electric drive is used for the explain above. Okay. So next is the part of this the block diagram. We have seen the electrical motors. So what about the electrical motor? Basically, these are DC motor, which will be a shunt motor, series motor, as well as a compound motor. Whenever we have used the AC motor, we have seen that this is basically induction motor. We know that there are two types of induction motor. One is a squirrel cage induction motor, another is a slip ring induction motor. Okay, as well as we have seen the brushless DC motor, stepper motor, etc. So whenever we have seen the DC motor have a number of disadvantages compared with the induction motor due to the presence of the commutator and brushes. We have seen that the commutator and brush are present in the DC motor. Okay, whereas we have seen the squirrel cage motor, the basic advantage is that the less costly than the DC motor. This is very important. Okay, highly rugged and simple. In case of earlier days, easy speed control DC motor were used. Okay, but with the development of the power electronics and the advantage of the AC motor drives have become more popular than the present days. Okay, so this type of electrical motors are in there for used in the DC drive, which will be we have seen in the block diagram of the electric drive. Okay, thank you.